mark it. Here's 1 diameter's worth. There's 2 diameters worth. 3 diameters worth, but does it make it all the way back around? No, we have this little extra bit, and this little extra bit is that 0.14159 something, 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 something. So we have 1 whole diameter, 2 whole diameters, 3. And that's where that number pi comes from, is in order to fill that in. That's where we get that, and it's kind of confusing because it's coming from something tangible, something that we can touch, something we can draw, but we're coming up with a number that never ends and never repeats. And that's kind of what blew the Greeks' mind when they were talking about pi, and when they found pi, they're like, what the heck is this? How is there a number that exists that never ends, never repeats? Especially when we can draw that and try and measure it. Kind of crazy, right? Just think I'm amazing. That was amazing. Pi! No? Okay. All right. So here we go with our notes. This is 10-1 continued. I'm just on the back side of my 10-1 notes. So my 10-1 is here. If you had room on the bottom, you're probably going to need 4 or 5 lines at least. We're going to write the definition of circumference and do one example quick. So this is 10-1 continued, if you need to write that to make yourself feel better. 10-1 continued. All right, about circumference here. Which is the distance around a circle. With most shapes, what do we call that distance around the shape? It starts with a P, perimeter. So this is really just the perimeter, but we call it circumference because it's going around a point. And there's 2 formulas we can use for circumference. The first formula is using that diameter. So circumference equals, how many diameters went around that circle again? There's that 3.14, right? So we do pi times diameter, and we use this symbol for pi. This is the Greek letter pi, times diameter. And if you want to make that note, that's pi, P-I. And okay, there's a symbol for pi. It's right here. It's next to the 4. So we can throw in pi, and it'll tell us it's 3.141592654. 1415924. And then it keeps going on and on and on. And that's a big mystery of math. People are trying to prove that there is an end to pi, or that there is a repetition. At some point it does repeat. It's a big thing. If you can figure that out, you will make lots and lots of money and probably win the Nobel Peace Prize. Okay, another way to find circumference is if we take that diameter. And instead of saying diameter, if we want to use the radius. How can I make a radius equal to a diameter, the same? Multiply by 2. So pi times 2r. So we can use either one of these. Generally, when we see that pi times 2r, we don't like that 2 next to that r because it just looks goofy. That we put pi first, and the r is last. So for some reason, we just like to rearrange that so it's 2 pi r. Well, it's the same thing, it's just rearranged. We just took it apart. Instead of doing pi times 2, we just flip those around. 2 pi r. So biggest thing with these circumference problems is figuring out which formula to use. Are we going to use pi times diameter, or are we going to use 2 pi times the radius? So if I have a circle here, do your best to draw your best circle there. And this is labeled 13 centimeters. Really hard to see, sorry. 13 centimeters. In this picture here, would we use pi times diameter or 2 pi times radius? 2 pi r. Why would we use 2 pi r? Because this r is that 13 is the radius. So biggest thing here is identity, or do you have your diameter? And because we have our radius, we'll use our 2 pi r. Circumference is 2 times pi times, what's our radius? 13. We're going to put that into Desmos or into our calculator. Now when we put it into our calculator, we want to use the pi symbol because our calculator is going to use as far as our calculator knows of pi. So on Desmos, it's right next to this 4 is pi. If you use your actual calculator on your phone, an iPhone calculator, you have to unlock it, and you have to unlock your rotation and tip sideways, and the pi is down here. Okay, if you have an Android, I think you go to your second menu. There's a button that says second, and it should be there. What? Yeah, if you tip it sideways. Oh, cool. All right, but I like to use Desmos because that's what we like you to use on your tests. So we do want to use that pi symbol. So 2 times pi. Oop, you can't see that. 2 times pi times 13. We get 81.68140899. Let's round to the nearest hundredth, so 2 decimal places. So 81 point. Do I want to keep that at 68 when I round, or do I want to round to 69? What number tells me to stay at 68? The next number, the 1. Good, so 81.61. Oh, 68 we said, sorry. Yeah. And when we measure distance, is it with centimeters, hours, inches? How are we measuring this one? Centimeters, and it's just a length, so it's just centimeters. It's not a squared or a cubed, just centimeters. All right, that's what we were supposed to do on Friday. We were going to do like this whole cool activity with it, but just because now we're running out of time and all these other good goofy things, and Miss Morrell and Miss Slater are just amazing humans, we decided not to do the rest. So we are going to be moving on to the next page. We're going to do 10-2. I recommend probably going on to the next page at this point. We have a glue-in that's going to take up pretty much the whole page. So if you need to take a picture of this because you walked in late or you weren't paying attention, this was the notes for 10-1. Finish, and we're going to move on to 10-2.
If you want to start gathering supplies, I'm passing out the glue-in right now. You'll need glue and some colors.
We're going to use 3 or 4 colored pencils today. I'm going to use 3.
You don't have to use the same ones as we do up there, but make sure you have ones that will make sense for you that you can part. You don't have to. Got it?
Okay, 10-2, we're measuring angles and arcs. And you have a glue-in, it's going to take up the whole paper. So just go ahead and glue that and throw it in. So measuring angles and arcs. As you're waiting for the glue, maybe title it or find your colored pencils. I'm going to use 3 colored pencils today. I'm going to use blue, pink, and yellow. Thank you for being flexible with us. I know that's not great to go from notes to notes. Normally we would do notes and then a practice, but like we said, we were going to do that yarn activity rather than just me showing you with the yarn. You guys were going to do that, and it was going to be super, super cool, but then we didn't do it. Sorry. So it's kind of a goofy day. I'm going to use blue, yellow, and pink today. If you'd like to use the same colors, go ahead and take those out. Otherwise, just grab 3 other colors. I recommend using at least 3 colors today. If you want to use more than 3, you could. I'm going to use some colors to color coordinate this top part. That's where I'm going to use the 3 colors. And then I might just use some colors just to mark up the bottom, but it won't actually match up. It'll be a little goofy. Alright, I'm going to get started in about 30 more seconds, so give you some time to get those colors out, get your glue in. If you need to pass that around. Seeing a couple people still glue. Alright, so first off we're going to talk about a central angle. When we look at the word central, what word is in that word central? Or what does it look like? What's our base word? Center. So it's an angle with the vertex, or with a vertex, at the center of a circle. An angle with a vertex at the center of a circle. So in this one, they gave us some angle numbers. We have angles 1, 2, 3, and 4, and those are at the center. So these are all central angles. And how much should all the central angles add up to? 360. So all of them add to 360, if you want to put that in there. That's something that we need to know. Some of you might know that. You might not need to write that. Now an arc is a shape. Okay? And in an arc, in the circle, it's going to be a part of the circumference. So an arc is part of the circumference, and we're going to be doing just part of it. It's like we're starting at one of the points on the circle, and we're going to end at a different point. And that would create that arc. So if I started at B, and I had to end at P, I would follow that outside arc there. Okay. To designate an arc, we use, it's kind of like our segment symbol that goes above the letters. But we draw a little arc, the part of the circle, saying that it is part of a circle. I don't know, just repeating lots of words today. All right, we have 3 different types of arcs. We have a minor arc, a major arc, and a semicircle. So when you go to college and you have a major and a minor, what do you spend the most amount of time on? You generally spend the most amount of time on your major. That's what you would graduate with if you go to college. A minor, what does it mean to minor in something? I majored in math. So I spent the majority of my time on math in college. But I minored in education. How does that make me qualified for being a teacher? Does that mean I just took one class on how to be a teacher? No, I took a lot of classes on how to be a teacher, but did I take as many classes as my major? No, I took a lot more math classes than I took for my teaching, but I took some teaching classes. So a minor is just a smaller part. So a minor arc is going to be our shortest path. Okay, and it's the shortest path from point to point. So for every point, or every 2 points, when we look at their pathway, there's always either a minor arc or a major arc, except for the semicircles. Minor and major kind of go together. I'm going to use yellow for my minor arc today. So when I look at my shape here, if I want to go from K to P, I don't know where I got Q from. If I want to go K to P, and I want to go the shortest way, would I go Q, why do I keep saying Q? Would I go from K down to W to P, would that be the shortest way, or K, B to P? Would I go down and counterclockwise, or up and clockwise? Which one would be shorter, just based on how it looks? Down and counterclockwise, I'd go from K to W to P. So that's my minor arc. That would be my shortest way around that circle to start at K and end at P. A couple ways that we write this is we can do a little arc saying we're going to begin at K and end at P. If I only use 2 letters in my symbol for an arc, it's assumed we're going the shortest way. Okay, I'm going to say that again because that's really important. If I only use 2 letters in my arc, it's assumed it's a minor arc, and we're always going to go the shortest way. Go from K to P as quickly as you can. Okay? But arcs, we can also use multiple letters. So we could say that we're beginning at K, and then where do we walk to? What's our next point we would walk to? W. And where do we end at? P. So we can use 3 letters for a minor arc, or we can use 2 letters. Either way is the same way to say that same arc. So if you want to sneak an or in there so that you know it's either this one or that one, you could use either of those names. So if minor arc is the shortest path from point to point, what's a major arc? The longest path. The longest path from point to point is a major arc, because major means it's the majority, so we need to go the majority of the circle. We need to go the longest way. So again, if I want to begin at K and end at P, which point do I have to go through in order to go the longest way around? Would I go through W or B? B. It's just like walking the other part of the circle. Rather than going K, W, P, I'm going to walk the other way around the circle, but it's the long way around the circle. Okay, so for this major arc, we're starting at K, and then where am I walking to after K? I'm walking to B, and then I'm ending at P. So arcs can either have 2 letters, or they can have 3 letters. No more than 3. Okay, so if there was more points, we would just pick one of the points in between. But a major arc must use 3 letters. Okay, for a major arc, it must use 3 letters. That's really important, because if I only use 2 letters, we're assuming get there as quick as you can. Start at K, end at P. Go the fast way. If we're doing a major, we have to indicate which direction are we going around that circle. Now, in this circle, there are 2 points that it doesn't matter which way you go. You could go counterclockwise, or you could go clockwise, you could go up, or you could go down. But it doesn't matter the different ways, because both ways are going to be the same length. Between which 2 points is the same length? Either way. W and B. How come it's the same distance either direction for W and B? If I start at B and I go towards K and end at W, how is that the same distance as going from B to P to W? How far around the circle are we going? Yeah, halfway. So if I go from B to W, it doesn't matter which direction I go, because this way it's half. If I go the other way, it's also half. So that's our semicircle. It's where we're stuck in the middle. It doesn't matter which way we go. It's going to be the same distance either way. So it's exactly halfway around the circle. So when we say have a semicircle, it doesn't matter which way you travel, which direction. We could have gone, rather than going BKW, we could have gone to BPW. So this one, there's 3 ways to name this. Because it could be a minor arc or a major arc, because they're the same amount, we can just say that we're beginning at B and we're ending at W. Or we could write it with 3 letters, saying we're beginning at B, ending at W, but what point did we start? Okay. But that's the same distance as if we went around the other direction. So we could have gone from B to W, But what other point could we have stopped at? B, P. We could have gone the other direction, but either way, all three of those are going to indicate the same length and the same amount because it's halfway across that circle. All right, our last one is arc length, and this is going to be a formula. So you're going to want to make sure you're writing this one down very carefully because you're going to need that formula on your test and on your practice and tomorrow when we do a different practice. Okay, arc length is the distance of the arc. So the distance of K to P. I want to start at K and I want to go to P. I'm actually measuring how far is that. How long will that be? Okay, and we know that the whole circumference, how long is a whole circumference? What was the formula for circumference? Pi times diameter or 2 pi times radius. But we're not doing the whole circumference. We're only doing part of it. And we just talked about how much is the whole circle. How many degrees? What? 360 is the whole circle. So in order to find just the part with an x degree, we're going to say that the length, and we do a cursive L, so it's kind of this loopy-loop, that's an L, equals, we're going to take the x degrees out of the total degrees. And how many total degrees is the circle? 360 times the whole circumference. So we're saying we're going to take the part of the circle times the whole circumference, and the whole circumference is either pi times diameter, or we can use a different formula. We can do the length equals the part, x, over 360, times, what's our other formula for radius other than pi times diameter? 2 pi r, yep. And to choose which one we want to use is going to just be based on the information we're given. Are we given a diameter or are we given a radius? Okay, if we're given a radius, we could just do 2 times that radius and then use pi times diameter. If we're given a diameter, we could just divide that in half and do 2 pi r. Either way, we're going to get the same answer. All right, we're going to do kind of an example and a half. We're actually not going to quite finish these notes, but if you wanted to work ahead after you kind of understand what's happening, you can do that. So here we go for this first example. We have, it's G, K, J, H, and then this is an I. Okay. We know that we have an angle here of 128 degrees. Can anyone name that angle that's 128 degrees? Say that again? Ignore that, sorry. You're right to use how many letters? 3 letters. And what letter needs to be at the middle? G. So for this 128 degrees, what other 2 letters would we use? Where would we start? I. Okay, start at I, go to G, and then end at J. So I, G, J, that angle is 128. There's another angle that's 128 degrees. Does anyone remember? This goes way back to chapter 1. What? The vertical angles! Oh my gosh, Yusra, making me so happy. Vertical angles. So vertical means across, so this is also going to be 128 degrees. Can anyone name that angle? Good. HGK. Awesome. Nice job, out coffee. HGK is 128. How can I find this next angle right here, this HGI? What do you notice about HJ? HJ is a straight line, or it's half a circle. And how many degrees is half a circle, or how many degrees is a straight line? 180. So if I do 180 minus 128, that would be 52. Anyone else check their math on that? Yeah? So 52 degrees, which means this other part that's across from it is 52. What do we call those angles that are across from each other? You sort of said it first. Starts with a V. Vertical. Yeah, and vertical angles are always congruent. Oh my gosh, look at you using your mathematical terms. So exciting. All right, just so measure of angle HGI. So H to G up to I. What is the measure of that angle? 52. Now, another way we can measure central angles, or to label them, is instead of including that G, because every time we do the center, what's always in the center of our circle in this one? G. So to make it easier for ourselves, another way we can say that is the measure of the angle created by the arc. And the angle what's the arc that's created by that angle? It goes from H to I. So another way to label that is saying the angle created by that arc, H to I, or when we make that angle, the arc that's made by that, kind of vice versa. So in this one, when it says measure, it has the M in front. That's actually an angle that's created by the arc HK. So when I look at the arc HK, I'm going from H to K. Do I want to go straight to K, or do I want to go around the long way? Is this a major or a minor arc? I want to go straight there. So if I go straight there, the quickest way, is that major or minor? Minor, yeah. So I want to go H to K. When I go H to K, if I look at that angle that's created to the center, how many degrees is that central angle H to K? 128. Okay, now for our last one here, it says HKI. So look at that first. We're starting at H. When we go around the circle, we're going to go through K, and then we're going to end at I. H to K to I. Is that a major or a minor or a semicircle? It's a major. If I go HK to I, if I'm going to just use purple real quick, because I'm just throwing another color at you for fun. If I go H to K, all the way back up to I, that's the long way around the circle. And I want to find out how many degrees is created when I go H to K to I. So I want to find this outside angle. So how would I find that outside amount? From H to K all the way back up to I. We did go through J, it just didn't say that we went through J, it's assumed. How can I find the total amount of angles there? Yeah, add. Which numbers would I add together? 128 plus another 128 and a 52. I like to do it in order. If you did it that way, that's fine. I'm going to do 128 plus 52 plus 128. There's another way to do it, measurement. Yeah, 360 minus what? How come? Yeah, it stops at I. The minor arc there is 52. And are we including that part or not including that part? Not including it. So we're taking the whole and we're taking out the part that we're not including. Either way, we get the same answer. So we can do 128 plus 52 plus 128. And we get 308. Or we could do 360 minus 52. And we get 308. So either way, that measures 308 degrees. All right, last one for this one. We have the length of I to J. So our length of I to J. So first thing we need to know is we're going to use one of these formulas, and we need to have an x, and then either we need a radius or a diameter. So x is the central angle. So what is the central angle of I to J? pi to j, 128, so that's going to be our x. Now this, it gave us our a measurement here. It says GI is 4 centimeters. So G to I is 4. We need to decide, is G to I a radius or a diameter? A radius. So we have a radius equal to 4. Because it goes from the center to the edge. So now I'm going to use which formula? The x over 360 times pi times, or x over 360 times 2 pi r. The 2 pi r, good. So we're going to do x over 360. Our x is 128 over 360 times, and then we're doing this 2 pi r. So 2 pi times, what's our radius? Radius is 4. So we're just plugging it into that formula because we're saying we're going to take that whole circumference, 2 pi r, but we only want 128 degrees of it. Okay, I highly recommend using Desmos because you can see the whole process and make sure that's getting plugged in correctly. So 128 over 360 times 2 pi times 4. Okay, if I round to the nearest hundredth, it says 8.936. So hundredth is 2 decimal places. When I round, do I want to keep it at 8.93 or round up to 8.94? 94, good. And what were we measuring in? Inches, centimeters, degrees, hours, minutes, centimeters. So we're measuring how far that length is. Alright, we're actually going to end there. We'll do our warm-up tomorrow. Will be this bottom problem. So if you want to work on this bottom problem, we'll check it tomorrow for our warm-up. Okay, but we are going to just go straight into our practice so that you have time to work on that before lunch.